Hey, Flip Geometry, how you doing? We are diving into our next lecture here. This is 4.2 congruent figures, and this is not a congruent triangle. What's your name? What's your name?
Hello.
Shiloh. Who's that? The Tegan? Yeah, these are my crazy kids. Okay, bye. We've used the congruent symbol and the word congruent before for points and segments and measures of angles and things like that. Now we're going to talk about congruent polygons and congruent shapes. Congruent circles are circles with congruent radii. They are not the same circle. They have the same measure. Two circles of the same measure. So congruent circles are circles with the same radii. Congruent polygons are polygons whose corresponding sides and corresponding angles are all congruent to each other. So if you have two polygons and they have the same angle measure or the same segment measure, then they're congruent. You can have congruent squares, and congruent hexagons, and congruent all kinds of things, but what we're going to use mostly in this class are congruent triangles, and you're going to be seeing congruent triangles for a long time, okay? These two triangles are congruent. The reason I know that they're congruent is because all the corresponding parts are congruent. So angle A is congruent to angle D. Angle C is congruent to angle F. Angle B is congruent to angle E. I'm sure you can hear Shiloh on the video. It's going to be awesome. And the segments here are congruent, AB and ED, and then FD and CA, and EF and CB. And so because all corresponding parts are congruent, then the triangles are congruent. Alrighty. Congruent triangles are triangles whose corresponding sides and corresponding angles then are congruent. And we use a little shorthand for this. You're going to use all the time in your geometric proofs that corresponding parts of congruent triangles are congruent. That's going to become something that is like tattooed on your soul. And so because you're going to be writing it so many times, we'll allow you to use a shorthand, CPCTC, corresponding parts of congruent triangles are congruent. You will see that all the time. Become friends with that statement. So as an example here, in this picture of a stable, if triangle UVW is congruent to triangle YXW, then we can list several things that are congruent. Angle U is congruent to angle Y. Angle U and angle Y are congruent because they're corresponding parts of congruent triangles. Angle V is congruent to angle X because they're corresponding parts of congruent triangles. And both sides of angle W here are congruent because they are corresponding parts of congruent triangles. We could also look at the legs here, or the legs here, or the legs here, and say that all of those legs are congruent because they are corresponding parts of congruent triangles. Very good. So we can use corresponding parts of congruent triangles to find out measures or lengths of things that we don't know. Find measure of angle x in example 1. That's measure of angle x right there. If triangle UVW is congruent to YXW, and the measure of angle U is 22 degrees, okay, and UWV is 30, okay. Well, now first I'm going to say, oh, well, the sum of the interior angles of a triangle is 180 degrees. So I have 22 and 30 and something giving me 180. 22 and 30 is 52. 52 from 180 is 128. So angle V has to be 128 degrees. And because X and V are corresponding parts of congruent triangles, then they are congruent. And so if angle V is 128, then so is angle X. All right, let's look at another example here. If in this figure BD and CE bisect each other, then I want to prove that these triangles are congruent. Okay, so I have here that EC and BD bisect each other. That means that bisectors result in equal segments, right? That EA and CA must be congruent. So these parts of the triangle are congruent to each other. I also have that BA and AD have to be congruent to each other because they bisect, right? This is bisected. And so I've got the legs here congruent. This leg and this leg are marked as congruent. This angle and this angle have to be congruent because they are vertical angle pairs. These two angles are marked as congruent, which means that if two angles inside triangles are congruent, then the third unknown angle are also congruent. So all parts of this triangle that are corresponding are also congruent, and I could prove through a very long proof that these two triangles are congruent. Let me just quickly show you what they do here. Don't bother writing all this down, just look at it. Make sure that you can track along, right? So BC and DE are congruent. Angle B is congruent to angle D, and BD and CE bisect each other. That's what we have been given. A is the midpoint of BD and CE. That's the definition of a segment bisector. Therefore, both sides of these triangles are congruent to each other, right? AB and AD are congruent, and AE and AC are congruent, and that's the definition of a midpoint. And angle BAC and DAE are congruent to each other because of the vertical angle theorem. And then I can also say that angle C is congruent to angle E, because if two angles in a triangle are congruent, then the third angle is also congruent. That's a short way of writing that out. Okay, angle, angle, then angle, angle, angle. And so therefore the two triangles are congruent because the definition of congruent triangles and the corresponding parts of all these two triangles are congruent. Okay, so that's a fairly long proof, but it uses lots of concepts we've talked about in the last couple of lectures. One more cluster of ideas. We know that to be equal, that there are some properties of equality that are always true when two things are equal. Part of that is the reflexive property, that something is congruent to itself. Congruence is just like equality, right? Congruence is reflexive, just like equality is reflexive. Congruence is symmetric. It doesn't matter what order you write it in. If x is congruent to y, then y is congruent to x. And congruence is transitive, that if x is congruent to y and y is congruent to z, then x is congruent to z. And so just like equality is reflexive, symmetric, and transitive, congruence is reflexive, symmetric, and transitive. That leads to three statements that all are exactly the same except for one word. So if you want to write these down as one statement and then like parentheses after, make the one word change to the other words, that works for me. But there is a theorem that says that triangle congruence is an equivalence relation, meaning it's reflexive, symmetric, and transitive. Triangle congruence is true for that. So is circle congruence is an equivalence relation, right? It's reflexive, it's symmetric, and it's transitive. And polygon congruence is an equivalence relation. It is reflexive, symmetric, and transitive. And that is it, ladies and gentlemen. If you have any questions, we'll talk about it tomorrow. And until then, God bless you. Jesus loves you, and so do I. Have a good night.